It's a pleasure to have you here. Can you please introduce yourself?
Pleasure to be here. Hey, I'm Ed. Um, I'm based in London. I'm Portuguese, and I'm building the Valantis protocol with my team at the moment.
And what's your background?
So, my education, I started by doing an undergrad in physics a couple of years ago. Then, that just I got very interested into machine learning and AI. Um, I did a bit of programming in my undergrad, but like it was not really like proper software engineering. It was just like using programming to solve numerical problems in physics, which then became almost the same thing when I went to just to study maths to do my postgrad, sorry, my master's in machine learning. Um, During my time there, I worked in Formula One for a bit as well. So just trying to use these machine learning models to just predict overtakes during a race. Then I realized that I quite liked the idea between, merging computers and just crunching data to make predictions. So I ended up doing a PhD in the field. But then like something funny happened in the sense that I was like surrounded by a lot of colleagues that knew a lot about programming and high performance computing and so on. And it was quite striking to me that, kind of like how I felt as a researcher in AI was I just had like some, I was given some problem or some data set. I had to find a solution to get like to pretty good accuracy on the model or like just beat some benchmark to publish a paper. But it was quite striking to me that like all of my computing native colleagues that, knew quite a lot about software engineering, they were a lot more empowered because the thing is when you're good with programming, you have an idea, you want to go from A to B, and the programming languages and the software will just get it there. Like it might take some time, there might be some bugs, but you feel quite empowered to reach a target. But with AI, I didn't really feel like that because even though it was really powerful what you can do with these models, especially now in the post ChatGPT era, at a time it was more like I was just trying things around and in a very stressful manner without knowing if it's going to work. So it's very different from like the software engineering toolkit. So, like fast forward, I decided uh, to build a startup with a friend of mine when I was like in the middle of my PhD. So I put it on pause because that's what you do here in the UK. You don't quit PhDs, you put it on pause, I think. And and so like it was basically here in this startup that I got to learn a lot more about software engineering. So I was at a time like I was building what became GitHub Copilot maybe more than 2 years later. It was just like combining AI with like a VS Code editor to just do code completion, code summarization, and things like that. I learned also a painful lesson at the time, which is you know you can't really train your own models from scratch because that costs way too much money, right? GPT-3 at the time already cost 80 million. We didn't really have the budget to remotely train anything as good, even despite making like all the optimizations. So we ended up pivoting to other areas. Like then I was suddenly doing game engine programming and learning about Unity and just like they got me even deeper into systems programming, software engineering. Uh, and it was like probably like the bull market of 2021 that I just got into crypto. But I did so by accident because there was no one around me that knew what was Ethereum or what was a crypto wallet or a private key. So in the beginning, it just started by everyone was talking about it on the news, and I felt really badly because I didn't even know what was a blockchain or a private key or, what even. I never heard the word Ethereum even at the time. So I just got to read a book. I got to know what's a private key and what's a blockchain in dummy terms. But then there was something that just got me curious about it, right? Because I always found like distributed systems quite interesting, even though I came from a different area. So it just the natural follow up was just to become a user, right? You get a bit of ETH, you're suddenly on Uniswap for the first time. Then mainnet is too expensive, you end up on BSC or Polygon to just like interact with the apps, etc. But like just because the time that it was, me as a crypto outsider, I just looked at it like a casino because that's exactly what was happening on all of the Uniswap V2 pools and like the trap tokens and so on. But the thing is, yes, I mean it was a casino. I lost like a small amount of money just playing around because of all of these trap tokens and pools. But like there was something there, right? You know, for me it was really powerful just to have the ability to just install a wallet and permissionless interact with all of these apps without going through KYC or a lot of hurdles that you would have in legacy systems, right? Um, so then the moment where I kind of like decided to be a bit more technical was when I just couldn't stop thinking about DeFi or crypto when like I was just curious, right? And then it comes to a point where you want to learn a bit how to code, because then you see like you go on DEX tools and like you click on liquidity pools, you see like these addresses with like a red mark, and it's basically like an MEV bot, right? And you could easily see that, okay, these people are making like 0.1 ETH, 0.2, sometimes more than that. But how are they doing it? Like, are they an HFT firm? Do they have collocation? Do they have like a special role? And just by doing some vague research, it turns out that not necessarily. Like, they're just like, hardworking people that compete in a mempool, and, whoever has the best code or the best strategy just ends up winning. For me, that was something new as well, because I came from a world where in order to do something in AI, like training a machine learning model or just getting the GPUs I need to publish a paper, I need to ask for permission, and then there's like budget considerations and a long queue to get the job submitted and so on. So for me, it was very interesting in NEO. I was like, okay, so I don't know too much about NFTs or like the ICOs or like the potential narratives, but are you telling me that me, as like someone who just randomly showed up, can actually write some code and compete on the same grounds without barriers? That was mind blowing, right? And that was the moment where I dropped almost everything that I was doing before to just learn about how the systems work. So next thing you know, you're doing your first Solidity course. Then you're writing your first contract to interact with Uniswap pools, and then you learn things like you learn to program in Go, to look into get source code, to reverse engineer it to be able to do something in a mempool. And like a couple of months later that I was, and the very first time that I was about to set up my system, actually it's the things that you don't know that kill you in the beginning, right? So I thought I had it all figured out. Like my system seemed to be working on testnet for a specific strategy that I was doing that only one other person was doing at a time. But I got wrecked because of salmonella tokens, right? Because the thing is, I might think, okay, if I simulate the state on top of the previous block, I'll get to know exactly what this transaction does. Well, salmonella tokens show you that's really not the case. And if you're not careful, you can actually like lose some funds and things like that. That happened on the first day. I learned the painful lesson that you need to have some checks and bounds. You can't just trust simulation. And so I changed the strategy to have like a token whitelist. I did decently well for like a couple of weeks. And this was basically like around April or May in 2021. So, Flashbots still only allowed to submit one bundle, and like multi-bundle submission only came afterwards. And once, multiple bundle submission came in, the strategy became a lot more difficult to run because I was doing it in a very strange way, right? So I knew that only one person was running the strategy, and I used that knowledge to my advantage. As in, when there's only one bot in the mempool running the same strategy, you don't even need to do complicated things like simulating the latest block and just like resubmitting a transaction. What I can actually do is you can just like look at the other searcher's transaction in the mempool. You just look at the call data, because at this point you know exactly what they're doing, right? They were trying to encode the call data with like some key that was in the decompiled contract, but the idea is I knew the strategy, I knew what the contract was doing, so I just take that call data, I don't simulate anything, I just submit my transaction like with some higher gas cost. So I was doing pretty well with that. Then multi-bundle submission came in. It just leaked away a lot of alpha because now other people can see the strategy. Then it became popular, and Just the fact that you have multiple bundles, it made sandwich trades a lot more pervasive on top of the block, where I wasn't really doing a sandwich trade, but like it was something that it overlaps in terms of like the same opportunities. So I realized that MEV is something a bit stressful, where like you may have something today, but then you need to adapt tomorrow, and like I didn't want to have this emotional roller coaster, because at this stage, honestly, like I was more in for the tech rather than the MEV and the profits itself. So yeah, that was the time that I stopped doing MEV, and I went to the next stage of like getting a part-time job.
Right. And how was the process of setting up your first MEV system? Because it's a bit of a black box. Many people don't know how to go about it. How did you figure it out on your own?
I was fortunate enough to accidentally go into the Flashbots Discord, because at the time it's not because you had a lot of content there at the time. I was still just learning the basics and just trying to do things on the fly. But the thing is, if you know what questions to ask, you will see that on the Flashbots Discord, it's just you go on Discord, you type specific keywords, you would find like maybe one or two people just dropping like little teasers about how you could go about doing it. And like I'm talking about people like Nathan Worsley, like a pretty popular MEV searcher, and some others. Basic things like how do you simulate a transaction to see the effects? Well, you had an answer there. You're like, okay, probably need to look into Geth. Like that was enough just to get me started, right? And then other things like optimizations, like you leave one way worth of a token balance in your smart contract, just not to have like the cold storage right the next time you do a transaction. You just start like to make a list of all of these tricks. But I would say that if you know what to look for, even if the information is scarce, you can still go a long way and just fill in the gaps as you go.
Yeah, that's a good advice. There's like just a lot of little nuggets out there, and if you're able to like pick them and put them together, everything you can see the big picture. And how did you find this guy doing the singular bot strategy at the time?
That was actually quite funny, because that was the time where I didn't even know how to code. So it was like I was just looking at like the red robots on DEX tools from the liquidity pools, and the pattern usually goes like, if you see a sandwich trade, you get like a robot, a normal trade, and then the robot again, right? But then I was seeing like a different kind of pattern, and I got intrigued, where basically was like there was the robot, then there was like a bunch of transactions, and there was even like a sandwicher in between, and then the robot sold at the very end. But the thing is, the robot was actually the one that made the most profit. It's like for an outsider like me, it just looked like this person was like just predicting the future, right? And for me, that was mind blowing. Like, okay, maybe the blockchain is not as accessible as I thought. It turns out it was actually like a very different kind of strategy. So what this robot bot was doing at the time was, so after I went deeper into like to looking at the block and like the transaction logs, what was happening is, on Uniswap v2, because there was like a ton of slippage, when you have like a pool with low liquidity, what it can do very easily is, like it's like 2021, right? You have new pools being launched all the time. Everyone has fear of missing out, and it's a very psychological effect, which is if you're like a regular user in the Uniswap UI and you just want to buy the token as soon as possible, your transaction reverts. What's your immediate instinct? So your immediate instinct is just resubmit as quickly as possible with higher slippage, right? And the bot was exploiting the psychological effect, because what was happening is he would see the first Uniswap router transaction, he would make it revert on purpose, but he had a very high conviction that the user would just try and buy it again, and he sold at the very end of the process. So it's all based on psychology, and once you see it from that perspective, then it makes a lot of sense.
Yeah, that's very cool. A lot of people assume that it's all a bunch of moon math and you have to, you know, be really on top of all those things. Well, probably you need to nowadays. You don't have that
Probably
kind of
nowadays, yeah.
opportunity, but it's always on like a psychological thing that people are just gonna um, increase the slippage a little bit. And do you still follow the MEV landscape? Do you have been keeping track of the different strategies and how they've changed since then?
Absolutely not at all. Like because the moment like I so then I started to work at Gelato like as a core developer, and I was also like part-time trying to finish my PhD because that's what I told myself. I said, okay, if I'm gonna get a new job and do something completely new, at least I want to try and finish my PhD. And at the time was a bit more like a sunk cost fallacy. Like I wasn't ready to fully give up yet on what I had built the previous years. Um, but the thing is, once you're in crypto, like every, it's like everything. There's like an exponential amount of information, right? It's literally impossible to keep track of everything. And if you want to be productive, like in whatever specific thing you're working on, you need to be really good at like switching off everything else. So for me, that had to happen with MEV. But it's not just because of that. It's also because usually what you see of write-ups on Twitter, they're already like the leak of alpha, right? Because the real MEV is being done by couple dozens of searchers. They're not even they might be friends in real life or online, but they don't share too much with each other. And what you will learn in 6 months, it will make you mind blown, but it will be like on the next wave already. It's super competitive, and it has quite very talented people. But yeah.
Yeah, and how did you go from that to getting your job at the Gelato Network?
Um, I mean, maybe a bit of luck as well. I mean, I was just looking for like a couple of positions in the space, and it seemed interesting what Gelato was building because it was this combination of like blockchain infrastructure, but at the same time with a ground in the application layer because it's a keeper network. You build up infrastructure for the apps, and for me, it just felt that I had a lot to learn because, if I learn quite a lot about these two domains, then I'll be fine for whatever I want to build next. Could be like a good background.
And do you think your MEV experience helped you secure that role?
Probably the only thing, right? Because if it wasn't for the MEV experience, I wouldn't even know what's a smart contract. So I had some knowledge, like like I just said, look, I may not be the most organized smart contract developer yet, but like here's a bot that I wrote. Here's like the highly optimized smart contract that looked terrible in assembly, but like at least like on the very specific niche, I knew what I was talking about. So that was enough just to get me in, I guess.
Yeah, and I think for you to do MEV, you need to know the if you're in network at a certain depth that just a regular dev wouldn't have to get into. So that's definitely an advantage as well.
Yeah, so it's kind of like I started from like a different side of the infrastructure stack, but then once I joined the team, then I was just learning a lot of things in the beginning, right? Because then I was like, okay, I actually shouldn't really write smart contracts like that because it's dangerous. They might have bugs. It doesn't have enough safeguards. And so then, that was the time where I looked into Open Zeppelin contracts, and you start to get a bit aware of best practices. And even on the application layer, I was using Go for the MEV bots, but now it's mostly about TypeScript and Ethers.js and things like that. Uh, then you learn about hard hat deploy, and like I would say over the first 4 to 5 months, it was just getting super familiar with the entire application layer stack for EVM chains.
And how did you see from that to your next job?
Yeah, so TLDR was that I really enjoyed like having this job at Gelato, which I started part time. But then like the final tipping point for my PhD was I was trying to just be on time for some paper deadline that I had in November that year or something, and it was becoming really stressful to manage both, right? Because it's like you do 4 or 5 hours a day of like blockchain work, and then you go to your PhD research where you have to do like proper experiments. You need to ask permission to get GPU time. The jobs don't go as planned, so you need to wait a couple of days just to get it running. So I was getting a bit frustrated because I was like, it seems that a PhD is just a sunk cost at this point, right? I would love to have finished it in a different time, but I just stumbled upon crypto and blockchain. So for me, like just going to ETH Lisbon, like my first in-person conference, and just by talking to the people and seeing how exciting the space was, I was like, okay, I think this is my kind of crowd. So I quit the PhD. I went full time in about December, and next thing I know, it was actually like probably the most stressful moment of my life, because it was just about like 1 week after I quit my PhD. Something happened, which is this. I'm not sure if you heard, but there was a post-mortem about GUni, one of the products that Gelato was building. So things ended up going well in the end, but there was like an exploit in a swap router that looked a lot like what the DYDX had just a couple of weeks earlier. Like we were lucky because like we got alerted about that exploit very early. So, there I was in the war room just 1 week after I started full time. We knew how to patch the bug. That's cool. But then the thing is, once you patch the bug and you escrow just about 26 million worth of funds at a time, then like it's gonna be open game for like the black hats, right? Because they will see, okay, something happened, like a lot of TVL was moved. What's going on here? And then it was like, okay, we just rescued the maybe 99% of the funds, but then you need to keep an eye for potential black hats, because the thing is, because of the nature of the bug was like an infinite approval, right? And the thing with infinite approvals is that you can't really sleep for a long time, because whenever the users goes to do the next transaction, a black hat could steal their funds that way. So what happened was we're like working day and night just to get like the searchers ready, just to front run these transactions to try and escrow securely for each user that has approved this contract. I think it was like there was at least one transaction where the same hacker that hacked the YDX a couple of weeks ago, probably like he just adjusted the server in a couple of hours. So he was able to get like maybe a few 100K from a user. But afterwards, like, we got some help from Flashbot's team and a bunch of searchers, and we managed to white hat rescue most of them afterwards. And then eventually, like, people just revoked their approvals and things became safe over time. That was like a huge learning lesson as well. And it just told me, okay, this is stressful, but I'm here for real. Like, I'm here for the tech and for the long term. After that, it was like I was building a couple of products, like things like Gelato Relay. I was working at the time. I worked on like the core infrastructure of the Keeper network, and I was just getting naturally drawn to DeFi, because GUnit, this project that started as like a product to make LPing easy on Uniswap v3, it was starting to become much more than that, because there was product market fit. They eventually spun off into their own company called Arrakis Finance. But just by like exposure to whatever they were doing at the time, I was like, okay, let me just try and read Uniswap v3 and like getting a bit familiar with concentrated liquidity and the latest of DEXs and DeFi. And it just felt like something super interesting to me, because it has to do with value exchange. There's like a lot of gas spent on that. There's a lot of users, and DEXs are like one of the biggest product market fits in crypto. So I just started by learning like in my free time over a couple of months, and that was like, of course, like in the free hours that I had from my full-time job. But then once I got more familiar, and like at the time I was also talking to my co-founder a lot, and it was just like we had a lot of conversations about the way DEXs have been designed for a couple of years, and the questions that came to mind were like, why do DEXs have to be so monolithic? That was the first question, because for the most part, maybe up until recently, building a DEX just looked like the following: as in, you're a team, you have like a pretty good idea for a new AMM or liquidity pool design, and then you just cram at it for a couple of months, but you do so in a very not so coordinated way. As in, doing that just means you define your own interface, you define your own set of smart contracts, completely oblivious to whatever else has been built out there. And what does that mean? Well, it means a couple of things, but one is that you don't really have the equivalent of like open Zeppelin contracts to get started in AMM development, right? You cannot stand on the shoulders of giants and just, reuse battle tested components so that you don't have to start your DEX from scratch. So that was the first thing. I would say the other one is the fact that because you don't design your liquidity pool with like a specific interface in mind, then it's going to be harder to just get aggregators and wallets on board to bring order flow. Because the thing is, you just launch a new contract with like a very different set of security assumptions, and now the aggregators need to look into it. They need to spend like countless dev resources to integrate it with this new thing, and then you may not even have like a lot of liquidity to start with. So it's going to be really difficult to get an initial order flow. And if you can't get the order flow, it's might be difficult to get a liquidity because the APRs are not there. So we're going more into a different question, as in, could you just think of like building a DEX as building like a set of reusable smart contract components? Because thing is, like, it's 2023, and I think that writing smart contracts, it looks a lot like writing hardware. Like, not because of the language or like the tooling that you have, but because of the time to development, all of the testing that you have to do, and the security cost and things like that, right? So if there was somehow a way to think of DEX as like reusable components, then that means that if you have a great idea in a DEX, but maybe someone already built a really nice module to compute dynamic swap fees that could help with impermanent mitigating LVR, or things like maybe someone built an order book and you just want to build a hybrid between an order book and an AMM. Maybe you don't need to build the order book from scratch, because you could just build a smart contract that inherits a lot of the callbacks and logic from there in a fairly safe way. So that's the direction that we were headed, right? But that was just one part. Of course, like, I'm just talking about a very low level architecture. I haven't said anything about what kind of AMM or DEX designs actually one could build to tap into new use cases or like fix new pain points. So that was kind of like the next thing on the line, where just through a lot of discussions, saying, okay, we look at Uniswap v3 and like it's very interesting. It has changed the DEX landscape completely. It was like a huge milestone innovation, but the way that v3 is approaching the problem is in saying, here's a common parameterization of liquidity. So long as everyone agrees that their primitive is the v3 range order, we have an efficient way to aggregate all of data at swap time. But the thing is, what if you want to run a super complex strategy, right? What if instead of having, one v3 range order at a time, you may need 100 of them? Maybe to shape a Gaussian distribution, or like to do something more complicated. Okay, that's just one part. It will cost you quite a bit of gas to set this up, but it's not just that, right? Because being concentrated liquidity design, and the fact that all of these 100 range orders, they're like independent from each other. Let's say that the price moves against you, and now you want to just adjust your perfect Gaussian, maybe rebalance to a new price range so that you can be in range, capture more fees, protect yourself, etc. The problem is it's going to cost you a lot of gas that's going to exceed the block gas limit, right? Because it takes you about, I would say, 200k gas to just burn a v3 range order and just to maintain a new price range. And you'd have to repeat this for all of them, so it's clearly not scalable. Like, even on the L2s, you're going to exceed the block gas limit. So we're just trying to think of a different question, as in, okay, instead of just having these, super flexible DEX that, tries to cater to a lot of people at the same time, why don't we just ask a different question, as in, why don't we acknowledge that, there are trade-offs when designing a DEX or an AMM? And so the question is not so much about how to build the one DEX that fits everyone's preferences, but more about how do I build one that is extremely domain specific, does one thing really well, but it's much better at that specific job. But you do that in a way which it gets very easy to aggregate with everything else, each one complementing each other. So that was the next thing that we had in mind. Aggregation of value exchange logic in the most efficient way that we could think, which I'm going to talk about in a bit. Specific DEX designs that solve some of the pain points that we've seen, like the one that I just discussed on liquidity management. And yeah, that's pretty much the motivation for the core of Valantis. Then I joined Nethermind, as and it was like kind of like an incubation process where I was there with my co-founder. He was already the CTO of Nethermind, and we just built a team. And then I think it was about in February this year that we spun off as our separate entity and stuff.
I see. And how do you begin to develop something that is supposed to mitigate so many of the issues? How do you build something that it's supposed to be so malleable, but at the same time secure?
I would say like modularity and reusability of code are your friends here, right? Because the approach that we took when designing like the liquidity pools, which is like basically what makes the core of a decentralized exchange, we just we looked at like everything that had happened in the past 4 or 5 years, and you can see some sort of like emergent structure. For example, like you can describe almost every single DEX that has been deployed until today as like a combination of the following components. Like there's a swap, in the swap function, at least what it looks like is, step one is, okay, you have some basic data checks. You always need that in every smart contract. And then the next step is you calculate like a swap fee. Most of the times, like these fees, like a constant immutable value, like you have on Uniswap pools. Sometimes it can be a bit more fancy and be dynamic and depend on volatility or momentum or other heuristics. Once you calculate the swap fee, now it comes like the core DEX logic, right? Where you inform the LP positions that here's the swap and here's the amount and here's the limit price or the amount required, and it just like readjusts the positions to fill in that order according to some conditions. And at the end, there's optional things like the pool might have an internal price oracle, and so if that's the case, you just update the oracle data accumulator with some new data, because maybe there's like a lending protocol or like a third-party protocol that really needs this decentralized oracle and hopes that it's robust enough. So for the most part, you can really see it like that. And then maybe there's other things like in some cases, like you may want to trade against a liquidity pool, but you want to have like more custom access management. For example, you may want to say something like, only this address can add liquidity or withdraw by default under some conditions, and things like if someone wants to add more utility to their ecosystem, they could do something like people that hold this NFT, they will get like a rebate in fees, or like, have like some conditional execution logic depending on identity or credentials. So that was like our starting point, I would say. So we built the first type of pool that it's called a sovereign pool. And the idea of a sovereign pool is that it's composed of reusable modules. It has the one that we call a swap fee module. It has what we call the liquidity module, which for the most part contains the DEX logic. It has an optional oracle module to accumulate the price data, and it has what we call a verifier module. So the cool thing is that if you're like now a DEX developer and you really see some really cool primitive that is already built in there, you may not need to start from scratch. It's like you literally just assemble these components as they are, which hopefully will have been audited and like have been battle tested, and you just add your own business logic. And one example which at least motivated us was at a time people were starting to explore dynamic fees, and now even more so. But the thing is, okay, let's assume that a researcher, like someone that does good work, comes up with like a better way to calculate trading fees dynamically, or like a better price oracle, or like something else, right? What would happen for the DEXs that have been deployed in the past 5 years that are in production? Well, it's actually not very easy or even possible for them to just upgrade to this better component, right? Because it would basically mean they have to rewrite the whole new protocol. There's security risks, there's audit costs. But if you had this modular pool design, you could let's say you have a pool today that has a Uniswap v2 liquidity module with constant product, and it has like the constant fee module, which maybe is not good enough for your LPs. Well, if someone just writes this module only once, to say, I want to calculate trading fees based on things like momentum and volatility or other heuristics, then all you need to do is swap out the previous module, put the new one, and so you don't have any code changes, you don't break anything else in the contract, and you have like very encapsulated security assumptions as well.
And how would that swap occur? Is it like a governance proposal, or is it like yeah? How does it work?
Yeah, so each pool that gets deployed, it has the concept of a pool manager. As in, basically, like, we decided to design the protocol like with very similar principles than the way Uniswap upgrades work, right? Because Uniswap upgrades is they come up with a new version, they deploy the smart contracts in an immutable way, and people just opt into these new structures. So basically, like, of course, like Valantis is going to have its own governance layer, which I can discuss in a bit, but we wanted to design the protocol so that governance has literally zero interference with regards to the core logic and some of the security assumptions. So basically, the way we're doing it is, people deploy their own pool, and they're like, they can choose whatever governance structure they want. It could be immutable if you want to have certain guarantees, or it could be governed by the LPs in that pool, or it could be governed by an external DAO or a multisig, etc. They would be the ones to swap it out.
I see. And let's step back a little bit and trying to look at it from a high level perspective. What are the major components that you have going on for this whole thing to work? You have your different pools, you have your different modules. Can you give us an overview of all the pieces and how you guys piece them together?
Sure. So this is just like the first pool type, but I think it's the easier one to explain. Then we're going to move on to the next one. So in this modular construction, so one simple example, like, so for example, like one of the models that we built, basically like we call like DEX designs liquidity modules. Each one focus on like a different use case, but there is one that we call the Stitch liquidity module. And it's a bit of a strange name, so let's just unpack that for a second. So basically what it does is it tries to be like a more flexible replacement for what curve stable swap is doing. As in, curve stable swap is really good for if you want to trade like assets that are like one-to-one pegged. So the idea behind this one is it's a different construction where instead of having like the curve being determined in the autonomous way, it kind of, instead of the smart contract calculating all of the parameters, it's more like you specify kind of like the shape of your bonding curve, and you can do so like in a very gas efficient way. So what you can do, you can make statements such as, within this range of liquidity bounds, I want to follow like a low slippage curve, maybe close to linear. But if you go beyond these bounds, you will fall back into constant product. And so you can adjust this to like different assets. So you can adjust to stable assets. You can adjust to assets that trade at a slight premium above one, like some stable coins over collateralized stable coins. Or you can even have it working for like volatile pairs, like, ETH USDC, where the curve would adjust based on like some oracle or like some configuration that is specified. So the way in which you would go about deploying a pool here is, step one, you need to deploy what we call the pool contract. And that's basically just a low-level contract that is meant to, to hold the funds for the position. It follows like, the best smart contract practices that we could find. It exposes like the reentry locks if you want to make sure that no one is trying to reenter through the pool on other models that you depend on. So you deploy this liquidity module, you attach it to the pool, and then you may think about, okay, maybe I want a better way to calculate swap fees. And now you just go in on a menu and you pick, okay, I like this model because it has fees that adjust on volatility or like something else. You just plug it into the pool as well. And maybe in the first couple of months, you may decide, okay, this is good enough for my use case and just to get the ball rolling. And maybe later on, someone will say, I really like what you built here, but I would actually like to take your LP tokens and make them and integrate them in the lending protocol or something like that. So at a stage, what you can do is, if you need an oracle, you can just come into the pool again. You just put the price oracle there, and you can just read the prices from there with quantifiable security assumptions and economic security.
And how would that work with like plugging in any oracle? How are you guys making sure that that oracle is going to be sufficiently secure in some way?
So it depends on like the way you program them. So when I'm talking about Oracle here, I only mean that oracles that are like intrinsic to the pool, right? Oracles that just like accumulate some data and then take some sort of weighted averages. And so it depends on how you do it, but there's trade-offs here. So for example, if you want to ensure a high level of like, manipulation resistance, you can have like larger observation windows. You can have like different weighting terms in your formula. You can do truncation of observations. For example, you can say that if the swap was like above, I don't know, 100 million in one transaction, just cap it maybe to like 10 million to just amortize the effect that you have on the price oracle. That's a simple thing to do. But there's a couple tricks, right? And depending on how you want to find a sweet spot between how responsive your oracle is versus manipulation resistant, which you can quantify using off-chain simulations and by looking at liquidity locked in the pool, applications will have like a pretty decent overview as to whether they should make the trade-off or not.
Right. And so you have the different pools, and would the liquidity of all these pools reside in their pools themselves, or do they all congregate at some point in the whole ecosystem?
That's a good question. So I actually forgot, but another module that exists, it's not something that you need to write a lot of functions for, but it's this concept of like where funds should be stored, right? So the way I described it so far, just to keep things simple, is you would put the reserves into the pool, and sometimes that may or may not be a good idea, right? For example, it might be a good idea if your liquidity pool has rebase tokens like staked ETH, right? Because singleton contracts they're usually not equipped to handle rebase tokens because you need to be robust to change in balance that could happen at every block, and it requires like special kinds of considerations like rounding errors on transfers as well. So maybe if it's a rebase token, you would want to have it stored in the pool itself because the pool is already equipped to handle a lot of these considerations. But it's not like the only structure possible, because in this kind of pool design, you can also make a statement to say, I want the LPs to keep the funds by default in some shared smart contract. And you could call that a singleton, right? And at the same time, when a trader comes into this pool and says, look, I want to trade this token for that token, you could also tell the pool, look, instead of leaving the input tokens in the pool itself, just please transfer them directly to my singleton contract that I just specified. So in this way, like, it's an example where you can like have these gains of like inefficiency by keeping funds all in the same place, but you don't need to do so through the singleton architecture. It becomes more like an opt-in system where you choose, do I want to have them in the pool or do I want to have it somewhere else?
Okay, and you also mentioned that, for example, in the Uniswap architecture, gas is a very limiting factor depending on how often you want to change your position. And how are you able to mitigate that with this protocol?
Sure. So there was like a specific liquidity model design. So far I described this one called the Stitch ALM, which is an analog for continuous bonding curves. So the second one that I'm about to describe is something that it was really custom made for liquidity managers. So basically the way we approached the problem was we said, okay, the fundamental reason why it's difficult to do complex liquidity management on V3 is because it somehow treats all of these range orders as like different entities. And because they are different entities, that's the reason why the smart contracts needs to move, apply a transformation to one at a time. And that gets like to a linear increase in gas costs, which can become very large. But this model takes a different approach. So the idea is, the first thing that you're going to say is, there's only one liquidity position. And what does that mean? It means that now you don't need to see all of these liquidity bins or range orders as kind of separate. you can able to see them as more like, for example, a glued histogram, right? Because the way you would think about LP here, it becomes something like a liquidity manager just deploys the contract and they set the initial shape of liquidity. Let's say that it's a perfect Gaussian. They may do that with like maybe 100 or even 1,000 bins. So that's like a gas cost which they probably have to pay once just to get the ball rolling. But then what happens is, because you make the assumption that the entire position is glued into one, then you can basically think of this histogram as like just anchored to some shift variable. As in, the moment you say this entire histogram is the same and the bins are not like separate entities, what you can do is you can say, okay, now I just have this big chunk of liquidity with arbitrary complexity and shape. And if you want to update that in the price range, to do very efficient liquidity management, you just change literally like 1 or 2 storage slots. Because all you have to do, you need to change the anchor tick that implicitly moves all of the coordinates at once. And that's the reason why you go from like something that is linear in gas cost and that could exceed the block gas limit to something that costs about 30 to 35k gas.
And how would it look like if I wanted to change the shape of that liquidity, that bin, that giant glued bin?
So there's a couple of ways in which you can do it. So if you want to change the shape itself, there's some there's some things that you can do to make it easy. As in, let's say that your Gaussian is like this, and maybe you want to change like the leftmost portion. Let's say just like maybe the first 10 bins. So basically, what you can do is like there's going to be a function, a smart contract, where you can transverse all of these and just like change the weights in a way that does not affect the total mass of the distribution. And that's basically the reason why you're able to do local changes without having to override all of the other bins or even like the global properties of the distribution itself. But the powerful thing is, it might be that a lot of times you don't really need to change the shape per se. Maybe it's just enough for you to just shift to a new price range. One example is, let's say that you think that the market is moving against you, and you just want to like reposition your liquidity to a more favorable price range as soon as possible. So in this case, it's actually good enough if you just quickly craft the transaction, just to move the whole chunk of liquidity, let's say from a center of like ETH at price 2000 to ETH at price 2200. And with this very simple low gas cost transaction, it just protected your own position very efficiently without changing the composition of reserves or anything like that. As in, usually when you think about updating liquidity positions on concentrated liquidity DEXs like V3, people think about shifting and rebalancing as the same thing, right? And that has to do because of the properties of the invariant, where if you shift to a new price range, then the quantities that you should deposit on that given range need to change, so you do a rebalance. Here you don't have to do that. You just like first shift your price range to protect yourself, and if you're really confident that the price has stabilized around that area, then you can do a rebalance transaction, which means you take out a portion of liquidity in the position, you swap it against any trusted external AMM design, and then you put the reserves back into the position again.
Right, yeah, that makes sense. And before we were talking about the Stitch LM, the
Stitch liquidity model. Yep.
Can these models work with each other in some way?
Good question. So these specific two cannot, but now that takes me to the next part, which is, so sovereign pools, the thing is they're super flexible. They can literally support any kind of DEX logic, including this one and the Stitch liquidity module, but they were not meant for something that we're about to do next, which is like, we call it like super composability and dynamic routing. So now that leads us to a concept that we call universal pools. And this might seem like is perhaps like the most exotic thing that we just have to tell the world, because so the way it works is it's a liquidity pool where you can have multiple AMM designs at once. And the way it works is you could have, for example, the first AMM design could be this, GLA that I just mentioned. The second one could be something that looks like some sort of order book where the liquidity is aggregated in a specific discrete price. It gets filled and then you move on to the next tick. You could have something that looks like, for example, Trader Joe V2 because, it works with discrete prices and it's similar to the way Uniswap V3 works. And basically anything that has the structure of like working with discrete prices. And how does the algorithm work at the end? Why is aggregation so efficient here? Because what happens is, you have multiple AMMs, and the question you're trying to answer is, how can you like build some sort of like algorithm that optimally and efficiently gets quotes from all of these liquid DEX designs under the hood? As in, the problem statement is you're a trader or an aggregator or a solver. You call this liquidity pool saying, hey, I want to trade this token in for token out. How do you abstract away all of the complexity and aggregating things in an efficient way? So it does so by doing something we call generalized matching. So generalized matching is basically, it's a generalization of the matching engine algorithm that you have in central limit order books. Because like the TLDR of how a central limit order book works is, there's like this data structure containing limit orders, amounts, and prices. And the matching engine of the exchange is just gonna like, go through them in the order of price and time priority and just like fill the liquidity in the right order. So here it's a very an analogous way of thinking, except that you're not really going over static limit orders. You're actually going over smart contracts. And so it looks a lot like an internet protocol as well, in the sense that let's say you're a trader, you want to trade against this pool, and this pool has a bunch of liquidity models. Let's say it has, number one is this GLA, which is very efficient for liquidity management. It has a fairly efficient on-chain order book, and maybe a third one that looks like a hybrid. So what happens is you don't even need to know that those exist behind the scenes. It's like the pool is gonna look at your order and is gonna do like a handshake step. It's gonna ask each one of them to say, look, someone wants to do a swap. Here's my initial reference spot price. Here's like the limit price that this user has, and here's the amount. Would you like to participate in a swap? It asks each one of them in a sequence. And it's going to ask questions like, okay, if you want to participate in a swap, would you like to provide some liquidity at the very first pool price that we have? Some might say yes, others might say no, in which case it's going to say, okay, if you don't want to provide liquidity now, when would you like at which price would you be comfortable providing liquidity? So it turns out that having these, small tuples of information on each round, it's sufficient to construct something that makes it easy to aggregate. Because what happens is, once you get these bits of information for each, you're going to fill the order in price priority. As in, if one of the models gave you the best price, you start by filling that portion of the order, right? And only then you go to the next one at the next best price. And then you query them again in an iterative way until you either reach the limit price of the order or the swap has been completely filled.
And how does that querying work, specifically talking to the liquidity modules? Like, how would those parameters look like, and why would some liquidity module be more opinionated about providing liquidity in a price range and not the others? Like, how is that integrated?
So the cool thing is, like, from the perspective of the pool itself, they don't really need to know what's going on behind the scenes on liquidity models. Like, they just say, I have a very well-defined protocol to fill orders in the order of price priority. That's a sacred rule. Whatever they do internally doesn't matter. And so then the question becomes, it's a concentrated liquidity design that, just aggregates a lot of things in the same place. So the question becomes, what's like the risk profile of each liquidity model participant, right? Because, maybe let's say that, there's like an order book there and like Citadel is, happens to be deploying liquidity there. They might have they might know something that the market does not. And for that reason, they might be able to quote at like the best possible price for the user compared to maybe the AMM or like even the other like on-chain native players. But the thing is, like Citadel has like given like the best possible quote to the user, but assuming you still have some liquidity left to be filled, the other ones still get queried like in the order of fairness. And at the end of the swap, what happens is there's some accounting where you do a callback to each one of these and says, look, the swap terminated. Here's like the post conditions. You can now safely update your internal state and unlock your reentrancy guards and things like that. And all of the accounting happens at a stage as well.
And what decides in which order these smart contracts are queried? Because the situation in each one of them could be different at a certain time, and if you catch them at the bad time, it could have not fulfilled the trade that it could have fulfilled like 10 seconds ago. So is there like how do you define a priority order?
Good question. So there's this concept of like an initial ordering, as in whenever the solver or the aggregator or the trader comes into the pool, there's basically like a small array of call data that is the same size as like the number of liquidity models in the pool. You're basically able to say, I want to query these ones in the for the first time at this very specific ordering. And there might be some good reasons why you want to do that. For example, let's say that you're a solver and you care about gas costs. What you can do is you can give priority to the liquidity models that are simulated off chain and that you believe that are going to give you like the most liquidity per unit of gas cost. So this something allows you to do that. But after that initial communication step that happens like on the initial price of the pool, then the transition is going to happen like in order of price priority. As in, we're not really gonna make any more assumptions. It's more like we're just gonna ask them, okay, the pool gives the liquidity models a chance to provide their quoted initial price, and the next one to be queried is gonna be simply the one that has the best possible price for the user. Because that also means that it will consume the least amount of gas, right? Because basically it says that if you call liquidity module and you're able to completely fill the swap now, you don't need to call the next one. So you save on gas because of that.
And could I arbitrarily choose any order if I wanted to for some reason, or it's capped at that first layer of abstraction?
It's capped at the first layer of abstraction. As in, you only choose the ordering at the very start, and the reason for that is if you were just to choose any kind of arbitrary ordering, you could get into strange edge cases where. So the thing is, remember, the pool doesn't make assumptions about how the liquidity models look internally, and if the liquidity model looks a lot like an AMM, there's a critical property called path independence, right? As in, the AMM security assumptions rely on the fact that a certain price will only be given if all of the liquidity to the other side of that price has been filled already. Because like if you create like arbitrary orderings and like maybe skipping one instead of the others, what's going to happen is they the AMM will just become broken internally. And like when you break path independence and AMMs, it can be quite dangerous because it opens to what's called like round trip attacks, where basically a trader can do swaps in multiple directions and extract value from the LPs. So price priority is like it happens to be a necessary condition for them to coexist well in the same place. And it also has like this nice feature of like optimally routing the orders across all of these. Because one strange thing to think about is that routing can be very difficult in a monolithic paradigm, right? Because you have like hundreds of DEXs as separate protocols with super different pricing logic. And so like what often happens is if you're an aggregator, you can't really change the way these DEXs have been deployed, right? You just need to work on as a wrapper on top. So if you're an aggregator, interact with let's say 5 DEXs, you might need to do at least 10 token transfers because they're like separate entities. And even if you try your best, you're probably not even going to find the optimal routing problem, right? Because you might think it's like almost optimal, but then someone places a transaction on the wrong place in the block and your assumptions become wrong, right? So the cool thing about this one is that it doesn't work for every single AMM or DEX design, but for the ones that can be, fit into this interface and structure, the pool doesn't make any assumptions, and because of the price priority rule, you kind of get the optimal routing by construction. Meaning that if you're like a DEX developer, instead of just building your DEX as like in a very fragmented way, you can just comply with its interface and then have the guarantee that even if you don't have a lot of liquidity, you will get order flow basically on the same block almost, because most of the times it doesn't require change to off-chain code to just whitelist it into a pool.
And if I wanted to plug in any existing DEXs, like let's say I want to plug in Uniswap in this architecture, would I be able to, the existing Uniswap contract?
You could do that in theory, but I think it would kill a lot of the benefits, because what happens is these nice, a big part of these efficiency properties, it comes from the fact of, for example, let's say you have, 5 DEX designs plugged into the same pool that respect these rules. The best thing for like the user is actually for all of these liquidity models to agree we're going to keep the reserves in the same place, like maybe in the pool itself or somewhere else. That's nice because then the user or the aggregator, whenever they come to do a swap, they might interact with like 5 of these DEXs, but they only do 2 transfers, right? Which is a huge amount of gas savings. So if you were to interact with, let's say, a Uniswap pool or any deployed DEX for that matter, you could build like a wrapper contract, but you would need to do it in a way that kills the benefits, because maybe you have the liquidity on Uniswap at the start of a transaction, then you need to do just-in-time liquidity to place it on the AMM, give the quote, and then put it back. It adds a lot of gas costs, so it might not be feasible on mainnet.
I see. And at what level are the fees set? Because I imagine that Valantis would have its own fees, but then the DEXs that are the modules would also want to have their own set of fees. So how does that play out?
Yes, so that's a good question. We actually like by the way the protocol is designed, remember. So when I said that governance cannot make any decision whatsoever about the core pools, that also includes the fact that governance cannot forcibly charge fees to pool managers or liquidity providers. And so the approach that we're taking here is, as like building a system where like there's like, zero economic barriers for people to build on top and extend. And so that literally means that any team can just, take these smart contracts as just like a starting point, as they would take maybe the Open Zeppelin contracts. They can just reuse some of the models or like build their own. But they can basically govern every single aspect of like their ecosystem as if it were theirs. They can charge their protocol fees. They don't have to we don't forcibly charge anything. But how does that interplay? So the way we see things happening in the long run is, it's maybe what happened a bit with, Cosmos chains and the Cosmos hub, right? So you have this idea of like Cosmos chain, they are like aligned with Cosmos. They usually, they communicate through IBC. They might have some built-in economics that is beneficial to the Cosmos hub, or at least, some of them hope to have that. Whereas others may just want to use the Cosmos stack just to, quickly spin off their own chains, but in a way which they might not give too much value to the Cosmos ecosystem. And in either way, that's fine, right? Because at the end of the day, you have a mix of the two. So what I expect is going to happen is some pools are going to be completely isolated from the core protocol, while others are going to be like part of the ecosystem. And if they choose to be part of the ecosystem, then there could be like some perks in doing so, because there's gonna be like we're kind of like working on like a standards in place for how you could bring new liquidity models into production safely, or any module, where the idea is, even though we allow people to just permissionlessly deploy the pool contracts and customize as they wish without asking for permission, it's still good to have like at least an off-chain process to decide what makes a model go from like a proof of concept to production, right? And there's going to be guidelines like it maybe needs to have at least 1 or 2 audits. It needs to have like independent review by DAO participants. It needs to pass some on-chain proposal that puts that smart contract factory as part of like the protocol factory. because at a stage, people have like a central registry of things they might wish to deploy, and they have been vetted by security experts and DAO community. So there might be a lot of value in that, in breaking this system from concept into production as almost like public goods. We're following like a different model, where the idea is, let's say that you deploy Liquidity Pool, and if you just want to keep it isolated and you don't donate anything to the protocol, it's just like do your own thing, it's completely fine. But if you see value in things like being a bit more aligned with a DAO to get access to other grants programs and like other social benefits, then what you can do is you as the pool manager, you can choose to donate a portion of the swap fees that your pool has accrued. And the way it's going to work is you donate a portion of the fees, you send that into a special auction contract where those fees that could be, for example, in ETH and USDC, each one of these amount of tokens, they will be auctioned off over like a week period. And so the way it's going to work is, there might be a lot of pools doing that at the same time. So like the auction is like always running. And the idea is it's a mechanism that's going to look a lot like a gradual Dutch auction, where maybe there's some reference starting price, and then there's a couple of scenarios. Maybe someone buys like at the highest possible price, even if that's above fair market price at the time. Or if no one wants to buy, there's going to be a threshold at which there's going to be an arbitrage. So any searcher is going to be happy to buy Val on the open market, put in there and get the funds. And once that's done, those tokens, they will be burned. And like this process is happening concurrently across all of these pools, right? So what does that mean? It means that by doing this auction buyback and burning the Val, you now have like an approximation to what's like the pro rata amount of value that each pool contributed to the protocol, right? So you might have something like some pools send fees in ETH, others in USDC. Others might send only in ETH because the other token is not yet whitelisted. Like, let's say maybe there's a pool with Shiba and ETH, but Shiba hasn't been whitelisted yet, so they only contribute with ETH. And you have all of them contributing their fair share. And like the fair share that they contribute depends on two things, right? It depends on like the amount of organic weekly volume that they keep getting over time. And it depends on the amount of volume over time. Oh yes, and depends on like the share that they take out of the LPs, which shouldn't be too much. It will be bounded to a reasonable value, but the interplay between the two, it will get pools to give away more or less. So you have all of them like giving away some portion of the revenue. They're getting like Val tokens. They're burning the tokens, and so basically like at the end of each week, you're gonna like take a snapshot and say, okay, what's the amount of Val that each pool has burned so far? And so you might see things like maybe this pool has burned 20% of all the Val for the week, and so then you're going to use that as a reference to decide what's the amount of token that you should give away for that week. So that's where the concept of a gauge cap comes in. They will be able to use their token to just decide on a pro rata basis, what amount of maximum rewards should each pool get on a weekly basis. And so, for example, like a pool that has, let's say, 10% of like the token staked into that pool, they will get only a maximum of 10%, meaning that even if the LP in that pool tries to wash trade their way into, making more than 10%, they'll get capped, so there's no economic incentive to do that. That's sort of the idea.
Right, so if one pool becomes like the major contributor, they're still going to be capped at a certain limit.
Yeah. So the idea is like, remove governance from the equation and like trying to create this incentive where, so you have like almost like two players here. You have the pool managers that decide how much revenue should be contributed, and you have the protocol that like continuously adjusts like the caps of each pool. And maybe at the end of the day, what you expect is to have a combination of the pools that have the most organic volume, assuming that everyone is like competing on the same level, like percentage of fees donated. You expect that more organic volume of pools will lead towards governance increasing the cap for those pools, which will lead to LPs moving their liquidity to that pool, to the service of users.
I see. And what stage of development are you guys in right now?
We're currently being audited. We expect the audits to be finished by end of November, already assuming all the potential fixes that we need to do. There's also the timing where we're building our developer SDKs to make it easy to integrate with the protocol, building like all the off-chain components that you need, and like things like potential partnerships and like specific use cases that we're gonna reveal like in the next coming weeks as well.
Cool. I like the concept of being like having certified pools and also enabling the Wild West to exist. Like, some of the audited ones probably you guys can show in the user interface or something like that, and then if you want to export the backend, you have the non-audited pools that anything goes. I think there's a nice interplay and allows to cater for different scenarios in the future. For example, some pools might, depending on how like regulations come about, some pools might only be able to exist with QIC, but then you have all these other pools that don't care about QIC. So I think that's really cool, because something that we're seeing with the direction of things, that some DEXs might end up being KYC, and that sucks. But if you have something that's like immutable and it's a free-for-all kind of thing, I think that's pretty cool.
Yeah, it's like you kind of like you need to find the sweet spot between giving too much optionality and having the cost of fragmentation, right? Because it's nice to build this system where you don't enforce anyone in a specific pool or liquidity or module. It's like you just build it as a canvas. You provide some options, and people will figure out what they're most comfortable with. But depending on how much sovereignty they want to have, or like how isolated they want to be from each other, that might give some liquidity fragmentation. So to fight off on liquidity fragmentation, that's you have you have universal pools, the ones where all of these liquidity models are like coordinated in a nice way, but can keep their funds in the same place to yield some efficiencies. Or you can also do so through the sovereign pool that only has one liquidity module, but you can also say, I want the funds to be here by default, where the meaning of here could be like a singleton contract that people are comfortable pulling everything together there.
I'm very keen to see Valantis coming out of the gate, so
Appreciate
people
it.
can use it. And how long did it take for you guys to put all of this together?
So the initial design and research, I would say started about May or June last year. We started building it, the Solidity contracts, I think it was around September.
Yeah, that makes sense, because I imagine there must be so many things to figure out along the way, right? Because it seems like quite a complex architecture to get everything right and even understand what sort of things that could go wrong.
Yeah. I mean, it's a lot of trial and error, and like so, lessons learned like during the process, I would say, is that of course, I described a very ambitious protocol, and you as like a developer, you may have this temptation, okay, I want to build this extra module and I want to launch with this one and that one. But if you're not careful with the way you plan things, you may end up in a situation where you don't have enough time to do code coverage and just to clean up the repo and write documentation. And that probably means that you're probably going to have a lot of bugs that auditors may not even end up catching on time. So kind of like what we decided to do is like, instead of launching with the 5 liquidity models that we wanted to launch with, which sounds crazy, but like it's like 5 DEX designs in a sense. But in doing so, we had about almost 2 months of just like internal white hat hacking the protocol, right? As in, a team member writes a bunch of code, then someone else will write a test and try and break it, and then just rotate around. And the surprising thing is, it really teaches us to be a lot more humble about writing smart contract code, because there were so many bugs in places that we could never expect from like just initial tests that we had set up. So Yeah.
Yeah, it's hard. Writing smart contracts is hard. There's always something that you didn't think about. And something I wanted to ask you about as well is to talk about of your war room experience. How did that go? Like, give us a little bit of a story.
So first I have to say that, at a time we were super lucky because it was a war room situation that it was mitigated before it happened, right? For the most part. It's not as stressful as like, the black hat happened and then we will go to a war room. So of course there was still a lot of tension and stress, and like I would say that like the first day was we were lucky because there was like I think Yash, like I think he's a developer at Lemma. He was the one that initially saw the bug existed in his contract, very similar to the DEX. So like he got in touch with us. We it was a week, and so we stopped everything we were doing just to have like an action plan. And basically the action plan was we identified the bug. Uh, After the fact, there was also clear about a solution, and then there was like multiple team members working on different streams. So I was more like on my side, I was mostly like doing like the transaction submission infrastructure, because like the thing is, we were super lucky that it happened on Ethereum mainnet, because you have relays like the Flashbots relay, right? The thing is, you might have like the perfect transaction to white hat rescue your contract, but if like a generalized front runner or someone else just picks it up and you don't have an easy way to protect yourself against it, your white hack will probably not be successful. Like it's only going to work if you trust that the generalized front runner is generous enough to give away the funds. So we're very lucky on that, because we're able to split into multiple streams where some team members they work on like the custom contracts to securely escrow the funds. Other team members, they were working on like all the testing suite and like just everything they need to make sure that it's actually going to work. Others started to to reach out to other firms to see what they could do, if there's more knowledge they can get. On my side, it was mostly about thinking about how can you submit a transaction to the Flashbots relay, and then it comes to heuristics like reputation in the relay, right? So one heuristic that we had was so because we're going to do the transaction into a very new fresh address that has never interacted with the Flashbots relay, just to be cautious, because relay reputation could have been a thing. We're not sure. What we've done is we sent, I think it was like just one ETH to this address, or like we just made like a simple transaction through the relay, or like 3 or 4, I don't remember, just to say, okay, this address has interacted before, they've transacted X amount of ETH at least, so probably it's not the same thing as having like a fresh new address. So we had that as like our reputation thing, and then once everything was ready, we submitted to the relay. It was a very stressful moment because it either works or it doesn't, and there's still the chance of like getting like your block leaked by an uncle and like someone else still stealing your transaction and stuff. We were lucky because we pressed the button once, it didn't go through, but a second time it went through, and like I think it was about 26 million that got securely escrowed. And then security firms reached out to us to say, hey, what happened? Was this a bug? And we said, no, it's all good for now. It was a white hat, but now we need to keep an eye for open approvals and things like that. So the next couple of days were just about like writing searchers on a mempool to just front run transactions for the users in a good way to save the funds.
Yeah, that sounds hectic. Did you guys ever had some sort of role play or some sort of training for that kind of situation?
Um, Not really. I mean, I was very comfortable with the whole stack, because I've done a lot of things with like bundle submission on the Flashbots relay, both in my beginnings as an amateur MVP searcher, but like also later on when I was working on Gelato core infrastructure, where I added some support for that. So I was familiar across the stack, I would say the technical experience was there. Maybe not the social one, I would say, which is why we also got in touch with like the people at Flashbots. They were super helpful, and I would say it's a growth experience, right? I hope it never happens to me or like anyone ever again, but if it happens, you need to be prepared and just keep it cool.
Yeah, for sure, for sure. And is there any other ways for people to be involved with Valantis at the moment?
At the moment, I would say that we will definitely release a lot more content in the next few weeks. We're even like gonna attend some of the ETH conferences that you'll see on the calendar. But if anything that I said today sounds interesting, just please reach out to us. Like, if you're a protocol with pain points, like you would like more efficient ways to manage your concentrated liquidity, or maybe you want to have a concentrated liquidity distribution that has perfect composability because you get a fungible token, or things like you want to have like maybe more custom domain specific modules that fix one of your pain points and maybe help you to internalize more revenue to your protocol, please do reach out, because that's exactly the kind of use case we like to tap on. And I would say also, like, if your project supports rebase tokens, because they are not as easy to support in most contemporary DEXs, like we can also do something for that.
That's cool. That's cool. And is there any way that I could personally contribute in some way besides the podcast? Because I think it's a really cool project that takes an angle that I haven't seen anyone else take before, and I think it's like contributing positively for the ecosystem.
I look forward to having you and everyone else. And what I can say on that is, we want to make like the code open source. The Valantis DAO maybe will launch a couple of weeks or months after the initial protocol launch. And I would say, like, once information is public and there are some docs, just like ask questions, propose changes, iterate on the design. And if there's anything you would like to build, or anyone else, we please reach out to us and we can help as well.
Well, it's been a pleasure, man. I enjoyed the talk with you a lot.